Salutations, fellow homunculi. This problem, 28, implement strstr. Right, not too bad of a problem. The solution I'm going to show you is slightly suboptimal, but I think it's more intuitive, and then you can upgrade the problem as you upgrade your understanding. So, implement strstr. Return the index of the first occurrence of needle in haystack, or -1 if needle is not part of haystack. I'll make this a little bit bigger. Clarification, what should we return when needle is an empty string? This is a great question to ask during an interview. For the purpose of this problem, we will return 0 when needle is an empty string. So, before we even read the input, they already told us what to do, right? They said, if needle.length equals 0, return empty string. That's what they said to do. That's what we're going to do. So we're not even gonna wait to click run, right? Get it wrong, then remember to do it. So it's always good to knock those out early. So with our first example, right, we can see that haystack is equal to hello and needle is equal to LL. So this question is basically asking, right, does needle exist within the haystack? If it does, return the index of where that occurrence begins, right? And we can see that since arrays are 0 index, if we count 0, 1, 2, LL begins at 2, right? For this problem, we can see that input is AAA, needle is BBA. Needle clearly does not exist within this string, so we return -1. In example 3, per the problem's requirements, when needle is empty, we're returning, oh, no, it says return 0. Oops, my bad. But yeah. So what's the key intuition for this problem? So they're basically asking, right, find the string that exists. It's basically saying find needle string in haystack string, right? So how can you go about that? So technically, right, if we have to find something, right, so if you had to find 1 in a list, what would you do, right? Well, you could sort the list, right? Assuming the list isn't sorted, you could sort it, right, in ascending order, right? And then, actually, that would be kind of slow anyway, because you'd be bounded by n log n time. But either way, right, the best case you can do, right, is just look through every element in the array, so linear time, right? And then if you find the element, return it, right? If you get to the end and you haven't found it, return -1, right? Or return whatever that is. So we're going to implement the same thing here. And so we have to find needle in the haystack string, right? So we're going to iterate over the haystack string, right? And then the same way, right, we would find 1 if 1 existed in a list of numbers, right? Would say, hey, if our current number equals 1, return the index, right? We found 1, right? And so we're going to turn this, right, into the string version, right? And then we said, hey, if we make it through the entire string, right, or in the case that we're searching for 1, if we make it through the entire array of numbers, right, and we never once saw 1, right, then what do? We return -1, right, just like the problem said. If we can't find the string in the string, if we can't find 1 in our array of numbers, return -1, right? And so thinking about problems this way is one way to downgrade the complexity of the problem, right, and then modify the solution to, add in the extra complexities, right? Because clearly when you're searching through an array and looking for 1, you're only checking for 1 value, right? And here we're comparing strings. But what you're going to see is that the algorithms are completely the same, except what happens at the if statement, right? So we're going to iterate over the string. So we're going to say let index equal to 0, right? While index is less than haystack.length, right? Index plus plus. Right, and then I'm just going to close this out here, right? And so we said if we were looking for 1, right, we would just check if our current number is 1 and return the index if we found 1. So what does that look like when we're looking for a substring, right? So we know that our current, whatever we try to compare, whatever we're trying to get, right, that substring we're trying to create, right, we know that for sure it has to equal needle, right? So we're trying to find 1, right, in this array of 1s. The problem version of this, right, is trying to find needle in the haystack. So we're comparing something to needle. So needle is going to be fine here. So how do we get the string that we're looking for, right? So let's just say we're using this input example here, right? We're starting at H, right? We're starting at H, right? Our current index is 0, right? So I equals 0, right? So how do we get the substring, right? So we're at H, which is the current index, right? We want to compare it to needle. So needle, right, is LL. It's 2 characters long, right? So we have to say our current index, right, plus 2, is it equal to needle? So our current index is 0, right? And if we say plus 2, right, our index is going to be 2. So end is going to be 2, right? And then we're going to create a substring between this range. I equals 0, end is 2. What's that substring look like? Well, let's iterate. So our substring is going to be 0, 1, HE, right? Why aren't we touching 2, right? Because this substring function that we're going to use is exclusive of the end. Just like when you iterate with less than, right, you're excluding the length, like the final element, right? Or that's the final number, right? And so what we'll say is we'll just say, hey, is haystack dot substring starting at the 0th element, right, going to our index element, right, plus needle dot length, right, is it equal to needle, right? And if it is, then it said that we should return the index, right? And that's what we'll do. And then I'll remove this code up here, and we click run, and it works, right? And then we click submit, and it works, right? So what is the space and the time complexity, right? So if you take a look here, we're iterating over the entirety of haystack, right? And so the time complexity here, right, is actually going to be n times L. And why is that, right? So n is the length of the haystack, right? Because we're iterating over the entire haystack length, right? And why are we multiplying it by L, right? So for each iteration, right, for each index we stop at, right, in haystack, we have to do, right, a linear string comparison, right? What does that look like? It looks like us creating a substring, right, which is, in this case, in our first index, right, it was comparing HE is equal to LL, right? And how do you compare strings? Well, you literally just go through them one by one and check if they're the same. If they're not the same, right, then you return false. And so that's what's going to happen. And so why is it n times L? It's because for each iteration that we're going through the haystack, we have to execute L operations, so length of the needle operations, to compare the strings, right? And so this is n by L, right, where n is the length of the haystack, right, and L is the length of the needle. And so what's the space complexity, right? So we're not using recursion, we're not using any data structures, right? We're not using any extensive variables or anything like that. And most importantly, right, are the variables that we're using to solve this solution, right, aren't scaling with the input to the function. And so if all those indicators are false, right, then this is going to be a constant space solution. And so this time complexity is O of n by L, right, and this space complexity, right, is constant space. And so this is implement strstr.